Hello, welcome back. In this video, we are going to learn about logical addressing, part 1. So let's look at the agenda. We will start with introduction to IPv4 addresses. After that, classful addressing will be the point of discussion. Then, introduction to classless addressing will be done, followed by network address translation or NAT. Introduction to IPv4 addresses. You see, the devices that are connected to the network or the internet should be understandable by some address space. For example, if you want to send any message from one computer to the other connected through the internet, a proper address must be there. I mean to say, the global addressing scheme should be maintained, and this addressing is known as the logical addressing. The first version of internet is the IPv4 addressing scheme, and here we are going to start with the IPv4 addressing scheme. Now, IPv4 is a 32-bit addressing scheme. 32 bits means the address consists of 32 bits. So, if there are 32 bits in an address, so how many addresses will be there? 2 to the power 32 addresses. So, this is the addressing space of IPv4. Now, there are two types of notations for IPv4. One is called the binary notation and the other one is called the dotted decimal notation. Now let us consider dotted decimal notation. Let us consider this number. Let's say 192.3.56.5. So this is an address of class C. Later on we will see what are the different classes of IP addressing scheme. Now this is the dotted decimal notation, which means the addresses, the 32-bit addresses are separated by decimal numbers, dotted decimal numbers. So this is 192. So this is the first part, separated by a dotted decimal, second part, followed by third part and the fourth part. Now the same thing, if you convert this number to a binary number, then this is known as the binary notation. For example, we can have, since there's 32 bits, they are divided into 8 bits. So 8 bits means 1 byte. So there will be 4 bytes, 1, 2, 3, 4. Each byte consisting of 8 number of bits. So we can have it like this, 0, 1. So this is the first block of addresses. Second, we can have this is the second block, followed by third block and fourth block. So this is known as the binary notation of address. Let us now turn our attention to classful addressing. IPv4 has the concept of classes. There are 5 different classes: A, B, C, D and E. Now these class of addresses are defined as said previously by either binary notation or dotted decimal notation. Now let us understand these classes one by one. Since this is a 32-bit address, so there will be 4 bytes of data. So the first byte, if it starts with 0, then it is a class A address. If the first 2 bits of the first byte are 1 and 0, then this is a class B address. If the first 3 bits of the first byte of the address is 1, 1, 0, then it is a class C address. And if the first 4 bytes are 1, 1, 1, 0, it is a class D address. And if the first 4 bits are 1, 1, 1, 1, then it is a class E address. Now, let us see how the addressing is divided. Now, this address is divided into 2 parts. One is called the net ID part and the other one is called the host ID part. The net ID part basically gives us understanding of the network through which the addressing is understood, and the host ID part is the device that is connected to the network. Now let us understand the range of addresses of the different classes of classful addressing scheme. See here, let's consider class A address. It has 1 byte of net ID followed by 3 bytes of host ID. Now it starts from 0.0.0.0 to 127.255.255.255. And this is known as the masking. Masking is basically used to extract the network address. Next, we turn our attention to class B addressing. You see here, class B addressing consists of 2 bytes of net ID followed by 2 bytes of host ID. It starts from 128.0.0.0 to 191.255.255.255. And the masking is 255.255.0.0. For class C, there are 3 net ID bytes and 1 host ID byte. Starts from 192.0.0.0 to 223.255.255.255. And the masking is 255.255.255.0. Class D addressing is used for multicasting. And it starts with 224.0.0.0. So this is basically the group address. There is no separate parts of net ID and host ID as we have seen for other classes. And it goes up to 239.255.255.255 and there is no masking. Class E is used and it's reserved for future use. And here it starts with 240.0.0.0 and ends with 255.255.255.255 and here also there is no masking. Let us now understand the 3 very important terms. One is called subnetting, other one is supernetting and the address depletion part. Subnetting means dividing an address space into several different addresses. Like if this is the internet and from the internet there is a router. Through the router we are getting connected to the internal network. Here there may be a single address, let's say 192.3.5.0. If this is the network address that is allocated to a particular organization which is connected to the internet through this router. Now, internally there can be many addresses like 192.3.5.1, 192.3.5.2 and so on. So this is known as subnetting. Now, let us see what supernetting is all about. The address space is decreasing. Decreasing means there is some flaw with the addressing structure of classful addressing and hence the result is that more and more address space is required. Now we use Class C addressing. Here Class C addressing has large number of net IDs but fewer host IDs. So what we can do, we can combine several Class C addresses, like let's say Class 1, Class 2, Class 3. You can combine them to use it for your organization, and this is known as supernetting. Now, as we have seen, the address space is decreasing and there is a serious drawback of classful addressing. So, due to this depletion of address space, we now move over to IPv6 addressing, which is 128 bits. We will see in the later videos more about IPv6 addressing. Let's turn our attention to classless addressing. For classless addressing, we divide the addresses into several blocks. Now, masking is done in order to understand the network address, and we use here the CIDR notation. CIDR stands for classless interdomain routing. Now, the addressing is written in this form. As before, we have seen for classful addressing, the address is written and it is given a slash and then followed by N. Let's see how this is done. So, this is an example of classless addressing 205.16.37.52/29. So, in order to get the addresses of this address block, the first address block will be understood by setting the rightmost bits to 0. And which rightmost bits? 32 minus n. So 32 here in this case it will be 32 minus 29. So these rightmost bits will be set to 0 in order to get the first address. Similarly, in order to get the last address, you have to set 32 minus n rightmost bits to 1. So in this case 32 minus 29, rightmost bits will be set to 1. So the equivalent or the binary equivalent of this address is this one. Here, since n is 29, so 32 minus 29 will be 3. So in order to get the first address, you have to set the rightmost bits to 0. So here in the original address, these are the rightmost bits. You have to set all these bits to 0. So the first address will be 205.16.37.48. And in order to get the last address, you have to set the last 3 bits to 1. So the answer will be 205.16.37.55. There are some restrictions imposed on classless addressing. The block or the address block should be contiguous in nature. Number of addresses per block should be power of 2. The first address should be evenly divisible by number of addresses. Let's see this by the example. So this is an example here. The address block is 205.16.37.52 up to 205.16.37.55. So there are 4 addresses in this block, and you can see these are contiguous block because it starts with 52, 53, 54, 55. So the first restriction is applied in this example. Now the number of addresses per block should be power of 2. So since there are 4, so it is 2 to the power 2. So it is 4. So it is a power of 2. So the second one is also valid. And the third one, let's see, the first address should be evenly divisible by the number of address. If you convert the first address to decimal, so this will be like this. And if you divide it by number of address, which is 4, you get an integer number. So these are the restrictions that are imposed on classless addressing. Now this previously we have understood the masking. So in order to get the network address, we have to do masking, and in this case So if it is /n, you have to, in order to get the first address and the last address, you have to understand, we have already understood how to get the network address. So network address basically is the address which is not allocated to any of the devices that are connected to the particular network. Network address translation or NAT. Network address translation is used to convert private address to global addresses and vice versa. There are many home users or organizations that require large address spaces, but they are not given so. So the answer to this solution is network address translation. This is the range of addresses that have been allocated to be used by anybody without any license. So the range is 10.0.0.0 to 10.255.255.255. So total 2 to the power 24 address space. The second block is 172.16.0.0 to 172.31.255.255. So 2 to the power 20. The third block is 192.168.0.0 till 192.168.255.255. So 2 to the power 16 number of address spaces that can be used by anybody in network address translation. This is basically used for ISP and NAT. To summarize, in this video, we have learned about introduction to IPv4 addresses. We have touched upon classful addressing. We have looked into the 5 different classes A, B, C, D, and E. We have understood classless addressing. We have understood CIDR notation. We have touched upon network address translation. Thank you.